Hi.
Hi. So I'm with Korrus, and we're here sharing some of our human light interaction-based technologies. The focus of our booth here is about circadian rhythms. So we are showing illumination, so like lighting, light bulbs and that sort of thing, and displays that are designed to support daytime use and nighttime use. So this is a demo that shows how we can change the color objects. So if you zoom in on this little bit of the tail here, you'll see that the color of the tail, it becomes almost like one color. And then if we give it a few more seconds, you will see that the color of the bricks becomes much more different.
How does that happen?
So we're altering the composition of the spectrum of the white light in a way that you can't see. So if you look at the light, it just looks like white light. There's nothing to see, it's just white. But we're changing it in a way that allows us to manipulate the color of the Lego bricks on this model.
So you don't actually change the Lego bricks?
The Lego bricks are unchanged. That is just a off-the-shelf Lego model that you can go and buy from a Lego shop, I guess.
And you didn't magically replace them in front of my eyes?
No tricks. It's just by manipulating the properties of the light in a way that's hidden to your eyes. This is to sort of prove to you that I can do this. And I'm doing this not to change the color of Lego models, but I'm doing it to produce light that will help your body to just get good rest at night by eliminating the light that tells your body it's daytime. So for example, this light here, hold on, this light that just looks like white light is actually blue free. So even though it looks like ordinary light, it is light that is suitable for nighttime use, and that will not upset your circadian rhythm. If you want to try, over here we have this demo. So we have some diffraction lenses. Now let's see if we can do this with the camera.
Yeah.
So if we look through here, so we're trying to see, kind of point off to the side over here.
Yeah.
There we go. There we go. That's the spectrum of the light coming out of this bulb, and you will see, hang on, yeah, right kind of where my finger is, the light is missing. So that is the blue light that would tell you it's daytime. So if we look up at one of these fixtures on the ceiling, let's see if we can do this. So you'll see, I don't know if you can see that, but the blue, you can see now the blue clearly in the spectrum. So we have removed that from our product for nighttime, and in these ordinary light bulbs up on the top, you can still see it. So we have also done that, this is display week, so why would we have light bulbs? Well, we've done it with displays. So this is our display where we have removed the blue light for nighttime, and we've added in extra blue light for daytime, but we've done so in a way that's invisible. So up here, this display is changing. So hold on, this is kind of a new, so now it's on daytime mode. So this display has extra blue light, so it's telling you it's daytime. Sort of imagine the blue of impact of these displays kind of working together is what we see up here. Now we're going to a neutral mode, and in a few seconds it's going to change to red and very, very dim. And we're doing the circadian equivalent up here, but we're doing it in a way that you just can't see with the eye. So if you see we've got this red and dim, that's what we're doing up here, and there's really no change to the experience that you have here. So you can use your display to work or game or whatever, and it will change throughout the day and deliver light that is appropriate to you and support your circadian system.
Is it a backlight?
I mean, there are many ways to implement this, and we've developed technology solutions that apply to sort of LCD type displays, emissive displays, projection displays, e-ink, laser displays, like basically every type of display.
And my Huawei or somebody's Samsung or something, when they have a night kind of like eye protect
when
mode,
they do that, yeah. So
is it similar to what you're doing? Or
no, what we're doing is very, very different in how we're doing it. What they're doing is in the same direction, but we're achieving a much greater effect. And you see, so this is sort of what your display looks like normally. And then when you go to night shift, I think we're about to go to daytime instead. Okay, so if we wait a few more seconds, you'll see it go very, very red. That's sort of the amount of impact we're achieving. But if you look at night mode, it's not nearly so red as that. It's more of an orange tint. So if we wait just a second here, it's going to go red again. Okay, so this is much redder than your night shift on your phone, I think, but we're achieving that effect without changing the color at all. So you're getting all of those benefits without having to kind of lose out.
Where's your technology in this? It looks like
This is our technology. This one up here. These are ordinary displays where I'm changing the.
so. How is your technology in there? Is it by being the backlight?
It's a
of the
combination
LCD?
of hardware. Yeah, it's built into the whole system. It's a hardware implementation combined with software to make it work. And we've. This is an LCD display, but we've developed the technology to.
So you do a lot of engineering on LED.
Yeah.
You
Our
control it
expertise is
completely.
in controlling the composition of wavelengths to achieve certain outcomes.
Do they have to be calibrated very carefully at some kind of place before you ship, or
To make the
is it
colors-
automated?
I mean-
you have all mass production and
We don't have mass
Millions of
production
LEDs.
in displays yet. We do mass production of lights so far.
millions shipping.
Gosh, I don't know. I'm not sure how many, but it's a product that's out there in the market, and
Right.
these are installed all over the place.
And what are we seeing over there?
What are we seeing here? So this is another form factor. This is for spaces that don't have enough access to natural light. So if you have a room that is maybe in an apartment where you don't have too many windows, this can be installed. This is something that can either be installed as a sort of a temporary thing where you attach it to the wall, or it can be installed in the wall, and it will deliver circadian-appropriate light. So we have this kind of sky gradient for daytime, and at some point it will transition to more like a sunset kind of a thing. So it will be appropriate for nighttime use.
I need this in my Airbnb.
Yeah,
Quite,
no, quite
no
dark, is
windows.
it? Yeah.
Yeah.
This is a device that we produced with one of our research partners. So Korrus is engaged with universities across North America to do research in human circadian rhythms, and we're using our technology to help scientists do experiments that allow them to answer questions that they just haven't been able to tackle before. So that's what this is all about. Over here, we just turned it off, but we did have a zero blue gaming display. So the idea was that you would be able to,
Nice.
game
for
game
40 hours without sleeping, and then
Well-
still be okay.
And then, you probably need to sleep. But yeah, the idea is you can play it up until you want to go to sleep, and it won't suppress your melatonin, so it keeps your natural rhythms intact rather than upsetting
Nice.
the circadian rhythm.
So it's been a good display week.
Oh, it's been great. Yeah, no, there's been a lot of interest from a lot of different parties, so it's been really good. It's been really good.